my name is George Nee, and I'm a PhD student in Professor Chen's nanoengineering lab. And we're here today to tell you about our floating solar technology for desalinating seawater from the oceans. All right. So when I started preparing this presentation a few weeks ago, it was really cold in Boston, frigid outside. And I had thought, well, how great would it be if we could get away to somewhere very nice and warm and tropical, somewhere like the Virgin Islands or the Maldives. But then I remembered it's actually really challenging to live in these places, primarily due to the lack of water there. So when I visited the Virgin Islands a few years ago during Christmas, I actually had trouble showering while I was there. And the reason was because it hadn't rained for a few weeks, and the Virgin Islands depends heavily on rainwater collection as their main source of water. So in our lab, we're hoping to solve this challenge with our technology. We've developed a sort of technology where if you bring it outside, it'll spontaneously boil water and generate steam. So with this steam, you could potentially condense it and collect it as drinkable water, very pure. And our device works without any sort of external fuel sources, and it only works under solar energy. So you don't need any batteries or electricity or fuel. It operates when you place it under sunlight. We're now developing this technology into these rollable sheets of plastic that we can deploy on the oceans. When you spread them out over large areas of oceans, you can then harvest fresh water directly from the oceans. So with this technology, we're hoping to provide affordable water to tropical communities around the world. So one example of these tropical communities is the Maldives Islands. So this is a country composed of about 2,000 small islands. Many of these islands are smaller than a football field, and it has a population of around 350,000 people. Their main source of water is rainwater collection, and in fact, most homes have a small tank attached to the side of the house, so there the water flows. The problem is, during the dry season in the Maldives, they don't have enough rainwater to meet their needs. And then this problem is getting worse as climate change takes effect. The dry season gets more severe. So when Maldivans run out of rainwater, they primarily turn to bottled, desalinated water as their alternative source. And the problem is they pay enormous amounts for this bottled water. They're paying roughly 10 to 100 times what we pay for desalinated water here in the US. And based on our initial studies, we think that they're spending around $20 million annually on this bottled water. So there are two reasons why that Maldivans are paying so much for bottled water. Number one, it costs a lot of energy to desalinate water. And because they're on islands, they have to ship in diesel fuel. So that increases the cost for water. The second reason is that to get cheap desalination, you really need to go to a large scale. So here in the US, we might have a desalination plant for 1 million people, like let's say a city the size of San Diego. But in the Maldives, when you have islands that are the size of a football field, you have maybe a few hundred or a few thousand people living there. And you really can't get the scale that you need to lower your cost. So these two problems of energy and scale are causing that's why the desalinated water is so expensive in the Maldives. So here, we've developed a technology that we think can solve this. We call our technology WISPs. It's a platform that floats in the ocean. It absorbs sunlight and uses that energy to evaporate water. And once you have that water, it's very pure. So WISP is composed of three widely produced materials. So number one, bubble wrap. Number two, styrofoam. And then lastly, we have this special solar selective coating, which is found in millions of homes worldwide in solar hot water heaters. This special selective coating works to absorb sunlight. And then once you generate heat with that sunlight, the three materials work together to accumulate the heat and increase the temperatures inside. So the bubble wrap prevents wind from convecting away the heat. The styrofoam prevents heat from conducting down to the cool ocean. And the solar selective coating prevents heat from radiating out to the environment in the form of infrared. The heat accumulates, and as you get higher temperatures, we then wick water to this hot region. And there, the water starts to evaporate very quickly because of the high temperatures. So with WISPs, we think that we've developed a very flexible platform. We can produce high temperature boiling point steam, or we can produce larger amounts of lower temperature but cooler vapor. So this this cooler vapor is more useful in applications like desalination, where you really just care about how much water you're producing, and you don't care at what temperature it is. But the high temperature steam is useful in other applications like disinfection or sterilization. So we also think that WISPs is a very affordable platform. So the device that we built in the lab costs roughly $5 in materials for 1 square meter. And just to give you some perspective, that 1 square meter can produce enough vapor in 1 day to supply the drinking needs of an individual, so roughly 4 liters per day. And if you estimate a lifetime of, let's say, 1 to 2 years for this technology, and you estimate the cost of water, it comes out roughly to be $2 to $3 per cubic meter. And you compare that to what the Maldivians are paying, $10 to $100 per cubic meter, and you can see that there's potentials for great savings for the Maldivians here. So currently, we're working on technology to collect the vapor, and on the business side, we're looking to flesh out fully the Maldives market. We've already sent some people out there. We've already sent some people out there to do initial market studies, and we found some pretty promising information. Maldivians are paying roughly 10 to 20% of their income for water. And we also found many organizations that are interested in doing pilot studies with us. So these are organizations like the UN, as well as local government councils that are in charge of the individual islands. So if you're interested in hearing more about our technology, just come talk to me or any of the other team members today during the poster sessions. Thank you.